In this lesson, using the concept of energy density, we are going to find the energy stored in a parallel plate capacitor. Energy density small u is defined as potential energy per unit volume. Capital U is potential energy, V here is volume. So this is always equal to half epsilon naught E square wherever electric field is present and there is no dielectric. If dielectric is present, replace epsilon naught by K into epsilon naught, where K is dielectric constant. So wherever electric field is present, the potential energy per unit volume is half epsilon naught E square. And therefore, the total potential energy will be given by integration of half epsilon naught E square dV. Here V is again volume. So we integrate it over the entire volume and we get this total potential energy. Half epsilon naught is anyway a constant. So if you just integrate E square dV. Now if E is constant, then it becomes very simple. Then the total potential energy will be half epsilon naught E square into volume. So this is the potential energy when E is constant. In a parallel plate capacitor, we know the electric field between the plates is constant. It is from plus to minus plate and it is given by sigma by epsilon naught, where sigma is charge per unit area. Therefore, the total potential energy here will be given by half epsilon naught E square. So that means epsilon naught into square of this, which will be Q square by A square, epsilon naught square. So half epsilon naught E square, and the volume of the space between the plates will be A into D. So you multiply this by A into D. One A will cancel and one epsilon naught will cancel. So basically we will get Q square by 2 epsilon naught A by D, and epsilon naught A by D is capacitance. So therefore we get Q square by 2C. So we have learned that the energy per unit volume is called energy density. Wherever electric field is present, energy density is given by half epsilon naught E square. If E is varying, we have to do integration. If the electric field is uniform, like between the parallel plates of a capacitor, to find the total potential energy, we can just multiply half epsilon naught E square with volume, and that turns out to be Q square by 2C. So this is the energy stored in a parallel plate capacitor, Q square by 2C.